Hello, my name is Deniz Eren Eroğluer and this is my Physics 101 Labratory project. In this project, I aim to investigate how elastic different collision surfaces are and how this elasticity is connected to energy loss during impact. When a collision occurs, not all the kinetic energy is returned. Some of it is absorbed or dispersed or converted into other energy types such as heat or sound. And to study this, I used an airtable system to reduce the friction as much as possible, and a spark timing system which can record the position of the puck with fixed time intervals. By measuring the motion of the puck before and after the impact, I calculated initial and final velocities, and from these values I estimated the coefficient of the restitution for each surface types, which I used as a way to represent how elastic a collision is occurring. The experiment was repeated 3 times for each surface types, including sponge, styrofoam, and metal puck-to-puck collision systems, in order to compare how different structures behave during impact.
Here you can see the sponge and the styrofoam surfaces that I used in this experiment. And here are the metal pucks. I use them for a rigid collision case. Here you can see the collision of the sponge surface with the puck. And here you can see the collision of the styrofoam surface with the puck. And this is metal puck-to-puck collision. Here are the collisions with the sponge. You can clearly notice that the rebound is shorter in every case of the collision. And these are the collision with the styrofoam surfaces. And here are the results for the metal puck-to-puck collisions.
The results of this experiment did not match with the theoretical expectations. Normally, rigid surfaces are expected to occur more elastic collisions and conserve more kinetic energy, whereas the softer surfaces like the sponge or the styrofoam in this case are expected to occur less elastic collisions and lose more energy. But in practice, the styrofoam showed the highest post-collision speed, and the sponge showed a moderate rebound, and the puck-to-puck metal collision resulted in the greatest energy loss. This indicated that the real collisions are not depending on just one factor, the surface rigidity. Factors such as how the materials stores and releases the energy, the internal gaps, vibration, sound, small deformation, and friction can also influence the outcome. And even the small experimental details like the misalignment, pressure during the release, or the specific type of the materials used may change the results significantly. For these reasons, the experiment does not perfectly represent an ideal theoretical model, but it demonstrates how sensitive collision behavior can be due to the physical properties of the materials used and the practical conditions in a real environment.